Hello, and welcome to this video about bosons. Bosons are elementary particles with integer spin. There are two types of boson, scalar and gauge bosons. There are four gauge bosons which carry the fundamental forces. The first of these are the gluons. They are responsible for the strong interaction, which, as the name suggests, is the strongest of the fundamental forces. At a distance of 1 femtometer, its strength is 137 times stronger than electromagnetism, 1 million times stronger than the weak force, and 10 to the 38 times stronger than gravity. It only has a maximum range of 3 femtometers, and at distances shorter than 0.7 femtometer, it becomes a repulsive force. There are 8 colors of gluons, and they can only interact with quarks and are responsible for keeping together quarks inside of hadrons such as protons and neutrons. The next are the virtual photons. These act in the same way as normal photons. They can travel at the speed of light in a vacuum and have zero rest mass. They only interact with charged particles and are the carrier for the electromagnetic force. This is the second strongest force and has an infinite range, but its strength does decay in accordance to an inverse square law. The first of the gauge bosons for the weak force are the W bosons. These can have either a positive one or a negative one charge, but they only have a range of about 10 to the minus 16 meters due to its large mass of 80 gigaelectron volts. They are responsible for beta decay, and they change the nature of particles by changing the flavor of quarks within them. The W boson's neutral cousins are the heavier Z bosons, which are responsible for interactions that take place with neutrinos. The fourth fundamental force is gravity, which is by far the weakest force. It has an infinite range and decreases with the inverse square law. However, no graviton or gravity carrier has been discovered yet. Finally, the only scalar boson discovered is the Higgs boson. This is the simplest manifestation of the Brout-Englert-Higgs mechanism, and which explains how W and Z bosons have mass. It also proves the Higgs field, which permeates through the universe and gives mass to matter as it passes through it. It has a mass of about 125 gigaelectron volts, which is the mass that was predicted by the standard model of particle physics. Thank you so much for watching, and I really hope you've learned something today.